In the previous video, I introduced you to the idea of conservation of momentum. Conservation of momentum is one of the most important ideas in all of physics. To give a quick rundown, let's say that we have a mass and the mass is moving along with a velocity v. We can then say that the momentum vector of the object is equal to its mass times its velocity vector. Conservation of momentum says that if you have a group of objects and objects in that group interact only with other objects in the same group, then we can say that the total momentum of that group of objects is a constant. Mathematically, we can say that if we have a process where objects in a group interact only with each other, then the total momentum at the beginning of the process, or in other words, sum over p initial, equals the total momentum at the end of the process, or in other words, sum over p final. In this class, when we use conservation of momentum for problem solving, we're going to use this handout here, Procedure 6, Conservation of Momentum. This handout is provided in the module introduction. So let's look at the problem that we're going to solve. I have here a child who is on a skateboard, and the child is holding a pumpkin. The child, the pumpkin, and the skateboard are moving together towards the right at some velocity v initial. Let's say that the child has a mass mc, 30 kilograms. The pumpkin has a mass mp, 5 kilograms. And let's say that this initial velocity of the child and pumpkin together is 3 meters per second. We're going to ignore the mass of the skateboard here. The statement of the problem says that the child will now throw the pumpkin to the right. We don't know how fast the pumpkin is thrown. After throwing the pumpkin to the right, the child recoils and begins moving to the left at 1 meter per second. We want to know how fast the pumpkin was thrown. Let's go to the handout. Step 1A says draw diagrams illustrating the initial and final situations. So this would be our initial situation here. Now let's draw the final situation. In the final situation, the pumpkin has already been thrown, so the child and the skateboard are moving together to the left, and the pumpkin is moving to the right. So in this final figure, we now have the child moving to the left. Here is that final velocity. The pumpkin is moving to the right at v pumpkin, which we're going to try and figure out. Going back to the handout, 1b says introduce a coordinate system. So as usual, let's just have a positive x direction pointing to the right. Moving on to step 2, it says for each situation of interest, write an expression for the total momentum. So what we want to do now is write down an expression for the total momentum in the initial situation and an expression for the total momentum in the final situation. In the initial situation, we have the child and the pumpkin moving together at velocity v initial. So I can write down an expression for the momentum of the child. That would be mass child times v initial. I add to that an expression for the momentum of the pumpkin. That would be mass pumpkin times v initial. Notice that these two terms can be combined into mass child plus mass pumpkin v initial. Why don't you try this next part on your own? Look at this final diagram and see if you can write down an expression for the total momentum in the final situation. Give that a shot on your own, then rejoin the video and see what I do. All right, in the final situation, we have the momentum of the child. I'm going to write that as mass child times velocity final. I probably should have done this earlier, but I'm going to just come into here and write v final equals minus 1 meter per second. Since we're taking v final to be minus 1 meters per second, this expression, mass of child times V final, is itself negative, and we just want to leave it like that. If you fall to the temptation of putting a minus sign in front, then you would have taken that negative quantity, put a minus sign in front, and then force the whole thing to be positive. We don't want that. V final is already negative, so we are leaving everything just like that so that it stays negative. Now let's go to the pumpkin. The final momentum of the pumpkin would be mass pumpkin times V pumpkin. So now we have done step 2 of the handout. Let's go to step 3. Step 3 says to write down the expression for conservation of momentum. In other words, we're going to write down that total momentum initial equals total momentum final, then make our substitutions, and then finish out the problem. So we write down total momentum initial equals total momentum final. Now you're going to take this expression here for the total initial momentum, stick it there. You're going to take this expression here for the total final momentum, stick it there. So you equate those two expressions and then solve for the velocity of the pumpkin after the throw. Remember, as usual, that you do your algebra symbolically first, and only after you have isolated the unknown, in this case Vp, then you plug in numerical values along with units. Give that a shot and then rejoin the video. So substituting into conservation of momentum now, I'm going to put mass child plus mass pumpkin times V initial on the left. So this whole expression here goes on the right. Mass child V final plus mass pumpkin V pumpkin. We're solving for the final velocity of the pumpkin, so we're just going to take this first term on the right, move it to the left, and then divide through by MP. Now to finish out the problem, all we need to do is flip the sides and make numerical substitutions along with units, and then just get our answer. Making the substitutions now, mass child plus mass pumpkin would be 35 kilograms. The initial, 3 meters per second. Minus mass child, 30 kilograms. Then V final minus 1 meter per second. All of that is divided by the mass of the pumpkin, 5 kilograms. When I substitute everything in, I get 21, and I'll let you do the unit checking on your own here, but the unit is then meters per second, so the child threw the pumpkin at 21 meters per second. In case you were wondering, I'm well aware that this is kind of a ridiculous speed for a 30 kilogram child to be throwing a 5 kilogram pumpkin.